Hi and Assalamualaikum. My name is Amanda Kistina and I am from group AS1143A2 and my group will be presenting the topic fat metabolism for our MIC 200 video presentation. Now before we can begin, let's understand the term fat metabolism separately. Starting off with fat, in simple terms, it is a major form of energy in our body and it acts as a fuel source. On the other hand, in biological terms, they are also known as lipids. Lipids are a family of organic compounds composed of fatty acids or derivatives of fatty acids. Now moving on to metabolism. It refers to the chemical processes that constantly happens in our body that allows us to live a normal functional life. So when you combine these definitions, you get a metabolic process that breaks down ingested fat into fatty acids and glycerol, and then turned into simpler compounds so that our cells can use it as a source of energy in our body. There are three sources of fats our body can use to metabolize, and this includes from the digestion of food, from stored fat in our adipose tissue, and from the synthesis of excess carbohydrates. Some interesting facts that you may not expect about fats or lipids is that they are hydrophobic, meaning that they cannot mix with water. This is due to the forming of non-polar covalent bonds between carbon and hydrogen. Now moving on to the second fun fact about lipids. Without any fat inside our body, our vital organs may be endangered due to lack of protection. Therefore, lipids act like a bubble wrap to protect our vital organs from any possible injury. And last but not least, you may never have thought that fat would be relevant to our nervous system, but it does. This is due to the fact that fat metabolism is related to the adipose tissue. And the adipose tissue is actually an interactive organ to our endocrine system. So basically, the adipose tissue communicates through hormone signals with other organs throughout our body, and this includes our central nervous system by transmitting nerve impulses.
Next, I will be talking about application of fats in industry and I'll be giving two examples of it. So first of all, we got the surfactant production. They act as the main raw materials for surfactant, short for surface active agents, leading in a crucial production of detergents and emulsifiers. Detergents such as laundry detergents are designed for washing clothes and typically comes in various forms such as powders, liquids, and pods. They contain surfactants that help break down and remove stains. You could say they play such a vital role in maintaining cleanliness and hygiene in both domestic and commercial settings. Second, we got cosmetic and personal care. Fats and oils are important in the formulation of cosmetic and personal products due to its contribution to the texture, stability, and moisturizing properties of many skincare items. Another lipids such as fatty acid, oils, and butters are often included in formulation to provide hydration and create a protective barrier on the skin. Examples include shea butter, cocoa butter, and various plant oils like jojoba oil.
I will continue the presentation about application of fat in industry, which is waste reduction and biofuel production. Waste reduction. Applying the example of fat metabolism to the concept of waste reduction includes reducing processes to reduce pointless or non-value added action. Much like the body effectively use fats for energy metabolism. Next is biofuel production. By using fats metabolism, biofuel like biodiesel can be produced by transforming fats, which sometimes come from biological sources. Lipids such as plant oils, animal fats, or microbes are commonly used in the process. Through the use of this action, industries can update their waste reduction activities with the effective resource observed in the body's fat metabolism. Industries can focus on minimizing waste in production processes, similar to how the body metabolizes fats without unnecessary byproducts. This involves recycling, reusing materials, and adopting sustainable waste management practices.
I'm going to talk about the biological function 1. Fat-soluble nutrients are especially important for good health and exhibit a variety of functions. Vitamin A, D, E, and K are the fat-soluble vitamins that are mainly found in food that containing fats. Some fat-soluble vitamins are also found naturally in fat-free foods such as green leafy vegetables, carrots, and broccoli. These vitamins are best absorbed when combined with food that containing fats. Furthermore, fats also increase the bioavailability of compounds that are also known as phytochemicals.
Next, I'm going to explain to you the fat metabolism in pancreas. Our pancreas creates a natural juice called pancreatic enzymes. It is to break down food, and each day our pancreas creates about 8 ounces of digestive juice filled with enzymes such as lipase, protease, and also amylase. Pancreatic lipase mainly secreted in the pancreatic acinar cells, and it is function to digest the fat in the duodenum. This is important because the pancreatic lipase participate in the digestion of fats such as triglycerides, cholesterol, and also phospholipids. This is so that the dietary fats can be fully utilized. It is important for the dietary fats to be fully utilized because the dietary fats are not just the source of energy. It is also functions as the structural building blocks of our body as it carries a fat-soluble vitamins such as vitamin A, D, E, and K. And it is also important for the growth and development of our body. The undigested proteins can cause problems to our body such as diabetes, pancreatitis, and also pancreatic cancer.
To sum up, in industrial and biological contexts, fat metabolism plays crucial roles in both. Without effective fat metabolism in both industrial and biological settings, negative consequences may occur. As example, inefficient fat metabolism in industry may impact processes like biodiesel production, hindering the sustainability generation of biofuels. Also, disrupted fat metabolism can lead to health issues such as obesity and metabolic disorder. Thus, understanding and optimizing fat metabolism in both contribute to advancement in sustainable energy and health sciences.